Anglais Point mud volcano is located in southwest Trinidad, near the village of Palo Seco at the end of Beach Camp Road. This map shows the location and distribution of mud volcanoes in onshore Trinidad. According to Higgin and Saunders 1974, the width of the flow is 60 meters and has a length of 230 meters. This is a single shield-type mud volcano on high ground at the back of the cliffs, with a mud glacier dropping steeply to the beach. Boulders, pebbles, and sand grains are found on the surface in the mud flow. Where the flow meets the sea is found an apron of large boulders, dominantly composed of sandstone. The bulk of the class are of cruise origin, with some of the sands being oil impregnated. Chert class are the second most common type, with Herrera sandstones and conglomerates also being found. Closest oil production from the Upper Cruise sands is the Primera Palo Seco lease, 2 kilometers to the northeast. The oil-saturated sands strongly suggest potential reservoirs nearby, and the occurrence of Herrera sands is an exploration target. On the left, the Kugler surface geology map indicates that the main structural element in the area is the southern anticline, which is made up of cruise age rocks with a core of what has been called the lower cruise clay pebble beds. Higgins and Saunders described the mud volcano as having an area of 0.5 hectares and about 75 meters in diameter. The pink dots indicate the mud vents mapped in the 1959 map, whereas the red dots indicate the May 2020 areas of activity. The topo map on the right illustrates the same thing. The little V's on the map indicate where mud volcanoes were mapped when the maps were done in 1977. This structural section shows that 2 wells, Apex Palo Seco 1 and 2, were drilled in the 1940s in the vicinity of the mud vents at Palo Seco. The lithology encountered is claystone with minor sands. This is similar to the coastal outcrops, where most of the claystones are parallel laminated and individual sands range from 2 to 4 feet in thickness. Considerable difficulty was experienced in drilling Apex Palo Seco 1 due to the presence of mud flows near the surface. When mud weights were raised to control the mud, circulation was lost and the well had to be abandoned. These drone photographs of the mud flow were taken between 2018 and 2020. There is significant slope failure at the head and sides of the flow in 2018. In January 2019, most of these have been partially removed or infilled by rainfall. The surface is smoother in 2020, probably due to a lack of new downslope movement. This schematic cross-section through the Angler Point area illustrates a potential relationship between the mud volcanism and coastal erosion. Eventually, coastal erosion, as it erodes the toe, it will trigger additional upslope failures and mud vents. This is a view of the mud glacier looking south. Visible in the middle is a large pressure ridge. These are found where there is a sudden change in the gradient of the valley. In the foreground are down to the south extensional faults caused by a combination of mud being intruded at the top of the slope and erosion at the toe of the slide, causing the slope to fail. In 2018, we see clearly visible crescentic and linear failures. The scarp faces are still fresh and relatively unaffected by rain action. They may have been the result of the August 21st, 2018 earthquake. The location of the active mud vents is highlighted by the green circles. On the right, in January 2019, we see that there's been significant downslope movement of the mud flow. Most of the center area has collapsed via a series of small, down to the south normal faults. Active mud activity is highlighted by the green circles once again. In May of 2020, the surface of the Tasik is fairly undisturbed. Near the top, we see a crescentic down to the south failure, and on the right is a north-northwest to south-southeast trending line of subsidence with small down to the south failures. Fine sand washed out of the mud accumulates in small depressions. The abrupt change in the slope and direction of the mud flow is due to the presence of a competent sand unit across the flow. This is the base of the mud flow. The large boulder is in front of the mud cliff face. On the right is an interpreted photograph of the toe of the mud flow. The rock highlighted in square has been in that position since at least 2006. This indicates a position of flow where it meets the sea is fairly unchanged. It may also mean the rate of wave erosion is equal to the movement of material downslope. The line of boulders represents the position of all mud flows. This May 2020 photograph shows that the rock highlighted in the red triangle has reappeared from 2019. The steep face at the toe of the flow indicates that wave erosion of at least greater than 10% has re-exposed the boulder. This suggests the flow has either been static or erosion has been greater than its advance. Activity at Angle Point is usually minimal, with minor cones about 4 inches high. Historical records, although between 2006 and 2020, the mud vent activity has remained fairly constant, with some small variations in location that may be caused by changes in the position and density of faults caused by the downslope movement of material. On the right, we see that the number of active vents has also remained fairly constant. The increase recorded in January 2019 may be the result of increased downslope movement of material by coastal erosion destabilizing the flow. Thanks for watching this video.